Good morning, friends and neighbors. Hey, time for another networking video. We're going to do a little networking and coffee this morning. I'm going to work through a series of topologies here with Packet Tracer, and we're going to take a couple of topologies that are routed topologies with simple switching, layer 2 connectivity, and then we're going to move them into VLANs, and then we'll transition to OSPF. So without further ado, we're going to take a look at topology number 1 here. That's on in the upper left here. And I'm just going to connect all of my nodes to the switch. And because I know what I'm going to do, I'm going to go ahead and use some of the low numbered ports and some of the high numbered ports. But that's all that I'm doing. And you can see from maybe the my labels here, I've got the 1 network and the 2 network. Okay, so that means that I will add some nodes to these networks. We'll make this 1.1, and we'll do some sort of standard stuff with the default gateways like that. Whoa, that's not going to work. There we go. And we'll do the same thing here. And we'll make you 192 168.1.2, and over here we have folks on the 2 network. So we'll keep it simple. We'll work into a little subnetting later on. Oops. 2.1 and this will be eventually it'll be 2.2. There we go. Alright, so that's our nodes. And of course we've got to do our router now. And thank you. So first we'll do int f0/0. We'll do our no shut. See what side we're working on. Now this is also in the low numbered ports. And so we'll do an IP address. Again, because I know what I'm about to do with VLANs. But here we go. This is going to be 1.254.0, and we'll say int f0/1. Oops. Helps if we tell the router where we want to go. And we'll say no shut here. And the IP address of this interface, 2.254. So we'll just provide a little bit of labeling here so to help us keep this straight. Whoops. This is actually on this side. And 1.254. Okay. Now the switch, remember that by default all ports are in VLAN 1, which is our management VLAN. It's called the management VLAN because it's the native VLAN and it's native in making it untagged. Okay. So if we do show VLAN, we can see that everybody is in VLAN 1. Now what I did was I connected one set of nodes. This is the 1 net, and then I connected another set of nodes here. But let's do a quick test here so that we know, sort of what we're about. So can I ping my gateway? I sure can. And can I ping other folks on my network? Yep. And then maybe the other side. Oh, come on now. So we have to wait for ARP to update. There we go. And alright, everybody has connectivity. Well, we'll know here in a second. Alright, everybody has connectivity. But all of these connections here are in VLAN 1. And so this is not what we want. So what I'm going to do is I'm going to move some of these hosts into VLAN 1. Now let me do a show int real quick. And we can see that I've connected to port 1, right? It's up, as we say, line protocol and the link. Same thing with 1, 2, and 3, and then the rest are down until we get to some of the later ones. Alright, so that's just a reminder about what I did, and we can mouse over them here and see sort of where they are. But without spending a whole lot of time on that, what I'm going to do is create a couple of VLANs. So I'm going to say interface range, and then we'll just do F0/1 to maybe, I don't know, 8. And I'm going to say switch port access. Now, good engineering design says that we want to tie the VLAN to the subnet if we can, or the network if we can. This is the one net, so that makes it harder. So I could do something like this. I could say 101. Oops. Like that. Okay. And then maybe what we'll do is, since I use the high numbered ranges, that would be 17 to 24. So something like this maybe. And then I'll say 102. Now if we take a look at the show VLAN here, we can see that I've added all of these ports to these different VLANs. Now importantly, the routers have no idea that that's going on. The hosts have no idea that I did that. But what I did was markedly change the traffic signature. Folks on one side of the switch can no longer see the broadcast or multicast traffic from the other side of the switch. Oh, by the way, the rest of the ports that I didn't touch, they remain in VLAN 1. Okay, so this is the way that we would want to do this. And just for fun, we'll make sure that we can still talk to everybody. There's the gateway. Maybe we'll speed things up here with an n-2, and we'll go to 2.1. Yep, so that's everybody on the other side. Okay, so this means that I just created VLANs here in our topology 1, and I separated the traffic. Now the lesson here is that it's not just about building a topology that's smarter as far as traffic goes. I could have done this with 2 switches, but then again, well, I would have had to use 2 switches if I wanted to separate the traffic, which is more power, more cooling needs, and more money. So in this case, what we could say is that each VLAN, right, sort of equals a network. Now obviously that's not exactly true because VLANs are at layer 2 and networks are at layer 3, but when you create VLANs, everybody in that VLAN has to be on the same IP addressing range. So that's the basic design of how we want to run VLANs and networks. So in this case, I had 2 networks, and therefore I had 2 VLANs that I created, and again I created them off of VLAN 1. Alright. So that is topology 1. So we'll pack this sort of up and we'll move it way over here on the side as far as we can go. There we go. Now let's take a look at topology number 2. Now topology number 2, I've decided to bump things up a little bit here, and we're going to subnet the 3-net. Now in this case I do have a bunch of different switches, but that's what we're going to do with we're going to manipulate this to get us to topology 3. So take a look at my first subnet. So if we remember our subnetting problems, if I do this, right, that means that I'm creating 4 subnets because I stole 2 bits from the host portion. And the first set of nodes are going to be in, well, they'll have a range of 0 to 63. My next subnet will be 3.64/26, and the range of host there will be 64 to 127. My next subnet would be 128/26, and so the range would be 128 to 191. And we have 192.168.3.192/26. And this range would be 192 to 255. So that's everybody in the class full address. Now, I'll touch on this again later, but I'm running 3 of those. So I would have to figure out what to do with this last one. But for right now, we'll just remember that if I'm dealing with this part of the topology, it's the 3net, but it's the 3.0/26. So all of these addresses that I use have to fall within that range. So we'll go ahead and make this host 3.1, but we have to remember we have to change the mask now to 192. And our default gateway will not be 254 as we like to use. It'll have to be, well, 63 is high in the range, but that's the broadcast, so we'll make it 62, like that. Okay, now while we're remembering that, we'll do that interface on the router. So I'm going to say int of 0/0. We'll do no shut to make sure we're dealing with the right one. And I will say IP address 192.168.3.62, but the mask, of course, will have to be 192. There we go. All right. Well, that makes this part of the network happy. Well, what about this middle part? We've got a pair of routers connected here, and we've got a host here. Well, that's our second range, so that's 64 to 127. So let's make this host down here, and maybe I'll provide some labels too. So this is 192.168.3.1. This was 3.62. And I'll go ahead and do the labels for, well, we'll do them for everybody up here. So this is going to be 64 to 127. My routers would be high in that range, so maybe 3.125 and 3.126, because 3.127 is the broadcast. And that would make this host, 168.3. maybe 65 as my low address in the range. Okay. So 192.168.3.65. Change our mask and our default gateway. Now this one is a little, it's not tricky, but we just have to remember that we're in the middle between two routers. Now normally you would pick the best default gateway for a host, but in this case it doesn't really matter because the topology is symmetrical. So I'll just go with 125. Okay. Now, while we're talking about labels here, this network is the 128 network, so 128 to 191. So a low address for a host might be 3.129. And my default gateway up here, or the router interface, might be 191 would be the broadcast, so we could make it 190. All right, so we'll finish our host configuration. .129, 192, and our gateway, like that. Well, now let's do our routers. So let's go to int f0/1. We'll do a no shut there. And our IP address will be 3.125 here. And lastly, we've got our router number 2. And int f0/0. No shut. There we go. And IP address, this will be 126. And don't forget our mask change. There we go. And we'll go f0/1, no shut. And this will be 3.190. All right. Well, let's take, well, just for fun, we'll take a look at a routing table, even though that's not really what we're about today. But we can see that we've got a couple of networks here that were subnetted. Now, we haven't actually finished our topology, right? We haven't finished the configuration because all we have is the directly connected networks, and we can see that we're subnetting. Well, what's the network that we haven't figured out how to get to? From router number 1, we do not know how to get to the 3.128 network. And from router number 2, we do not know how to get to the 3.0 network. So let's fix that with our static routes. So I'm going to say IP route. Well, this is router number 1, so that's this guy right here. We need to be able to get over here. So we need to get to 192.168.3.128. And this is where the mask is important in routing statements. We need to tell this router that it's actually a different network. It's not part of the class full. Who are we going to send this to? What's the IP address that we would send this to? Well, it's our neighbor on the .64 net, but it's not us. There we go. Okay, well, let's take a look at our routing table really quick. Do I have 3 networks? I do. And the router didn't complain at all. So I did, looks like I did it right, or at least the router's happy. Take a sip of coffee here. Alright, let's do the same thing over here, but we need to get to the 0 net. So I'm going to try to get to 192.168.3.0. Now that looks like a class full network, but it's not because of the mask. And how do we get there? Well, this is the other side of this network here, so it will be 125. Do a show IP route here, and there's our networks. Now, we're going to go for broke because we don't want this video to go too long. And we will just say, can I get to everybody? And I'll just try to ping 192.168.3. So we're going to go all the way across. Well, we'll do them both. We'll do 3.65. Now, we haven't updated any ARP tables yet, so we got ARP and ARP over here, or ARP right there. There we go. So that one works. Let's try 129. Now we got ARP over here. And uh-oh, did I make an oops? Did I forget to configure somebody? Alright, let's make sure that I got everybody here. 3.190. I'll fix this in real time so you can see that, you know, stuff happens. And show run 126.190. So I like that. Let's actually do a little troubleshooting here, and let's see how far I can get, and that'll tell us where this goes wrong. So we'll try 126 first. Well, that's done. There we go. We got 126. Let's try 190, the gateway. Well, that might be our problem right there. I may have fat-fingered a command. Alright, so let's check out our... So this looks good. Oh, there we go. I did fat finger it. I was talking about networks, and I put in the network address instead of the router interface. So I named this network here instead of this guy here. And yeah. Okay. I know that y'all out there like to think that I'm perfect. I know. But stuff happens. And let's try that again. We're going to go for broke. 129. Now we got to update our up tables again. Huzzah! Alright. Now this is just a straightforward routing topology, right, with static routes. So that's not really what we're talking about. What we're interested in here is what in the world is going on with these networks down here. And why do I have 3 switches? So what I'm going to do now is we're going to say, well, let's move topology 2 to topology 3. And what I'm going to do is I am going to eliminate, we're going to eliminate, oh, stop it, that switch right there. And we're going to eliminate that switch right there. Now I am going to connect my machines back here. I'm going to try and remember where everybody goes. And maybe I'll do this one step at a time. So this is connected to, all right, 24. All right, so I'm actually we're gonna disconnect my links here, and we'll just do them sort of one at a time. Now, so what I'm dealing with is this network over here first. And so on our switch, we're going to create our VLANs. Now, instead of saying a VLAN equals a network now what we're worried about is, well, a subnet behaves in the same way as a network, a class full network, except it's a smaller address space. So we're going to do the same thing with our VLANs. I'm going to say config T, and because I have more than them, maybe I'll just put 6 ports in there. But I'll say interface range F0/1 to 6. And I'm going to say, since again we're dealing with the the class full network here, we'll say switch port access VLAN 100. Okay. Now this middle network is the 64 network. And so what I want then, and I don't remember where I connected this guy, so I'm going to reconnect them. We know that we're going to use ports 1 through 6, so we'll start at 7. Oops, did I do the right? Okay. Let's see. You have to go to F0/0. It's a little bit of fun when you have to figure out, packet traces are so tightly packed. Alright, so we'll go 7 to 12 as the next one. So we'll do this and we'll go to port 8. So if I want to take the next group of ports then, I'll say interface range 7 to 12. And we will say, we'll make this 164. That'll help us keep it separate. And then what we're going to do is we have another router though, another router that has to be in that same VLAN, right? So we're going to put this guy in 9. Well, now what to do? So we're going to move this guy back over. All right. Oops. Now what to do with the rest? Well, let's create another VLAN. And this time we'll do 13 to maybe 18. And we'll make that, since this is the 128 net over here, we could just do 128. We could get away with that. Depending on which version of the operating system you have, you can go fairly high in your VLAN numbers. So I'm going to go ahead and do that. We'll stick with the convention. And now we need to go to all the way up to the 13 net, which also means that this host has to be in that same VLAN. So it looks a little crazy, right? It's confusing, but all that I've done here is, made my topology a little more efficient. And even though everybody's in the same switch, because I use VLANs, we're still separating all of the broadcast and multicast and unicast traffic. Let's take a quick look at our VLANs. So I've got these 3 VLANs created, right? There's one there. And there's a couple here. And so these are the VLANs that map to my subnets. So in this case, I could say something like, well, when you have a subnet, that's tied to a VLAN now. Okay? So same exact idea. Let's make sure that I'm not out of my mind. Let's make sure that it works. And I'm going to go for broke again. We'll go all the way across the topology. Now all the links went down. Now it's easy to screw up the cabling. So who knows what I may have done here. But we'll test it, we'll try it, we'll troubleshoot, and we'll go from there. But the key is that you got to get everybody on the same network into the same interfaces. And clearly this is not working. So we will see where I went wrong. So first up, we'll try my gateway. And these were the wires that I screwed up initially. So we'll see what happens here. So this is, oops. So F0/0, oh, that's going to 23. That's not right. You can't go to 23. No. You, sir, have to go very early on in our topology. Where are you connected now? 2. Okay. We should be better. See how it, I mean, I put it on the left-hand side and it shows up on the right-hand side. It's always a little confusing to me sometimes. Well, not always, sometimes. Alright, that looks okay. So let's try it again. I'm going to go for broke. We'll go all the way across. Well, maybe we'll take a second and do a little troubleshooting. See what happens. If it goes past 2, alright, that's a problem. So here we go. Let's try to get to my gateway. So that looks good. We're in the same VLAN. Let's try to get to, so what I'm going to do is I'm going to ping this interface, this PC, this interface, and then the last one, and that'll tell us where we go wrong. Now that's one way to do it. I could jump halfway and then go that way, but we'll do it, just sort of step by step. So the other side of the router is 125. That works. 65 is that host over there. And where did we put you? 8 and let's see. Oh no. Oh no. 7 should be the right one. That should be okay. Oh, never mind. Let's try it again because I just disconnected everything. Well, we have to wait for this to go forwarding. So what I'm going to do is I'm going to jump to the other side. Oops. Stick this over here. And can you ping your default gateway? 192.168.3.190. That works. We'll try the other side. We'll try this router right here. We're going to go 126. That looks good. All right. If we get to 125, then life is pretty good. Here we go. Alright, let's go back to our original host here, and we'll try to go all the way across again. Let's see, that's the router interface. Good. Alright, so a little futzing around, but everything works. Everything works. And all that we did was we got rid of that whole set of switches that we do not need. Okay, well, let's do this. Let's move to our topology number 4. And topology number 4, we're going to do OSPF. I'm going to do the exact same set of IP addresses and everything else, but we're going to do an OSPF topology. But we'll just have to wire it correctly. So what I'm going to do is I'm going to take these nodes in here and we're just going to supplant all of this stuff here. But I just realized that we're nearly at a half an hour now, so I'm gonna create part 2. We'll post them both today, and the second part will be the OSPF topology on the same thing.